Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Muhammad Reiyan Indra from Department of Electrical Engineering, Universitas Indonesia, and I'm here to explain my internship report results titled "The Analysis of SCADA Response to Frequency System Optimization Through AGC Operation at Java Bali Control Center." So here is the outlines or the table of contents of our internship report presentation. So the first thing I would like to explain the introduction. And so the electricity is one of the most important thing for meeting daily human needs that transmitted through substations across regions. And then it has conventional substations that are evolving into the automated ones to enhance the efficiency that it is executed by the implementation of SCADA that is operated currently at PTPL and WP2B, which enables real-time monitoring of the entire electrical network across Java, Madura, and Bari regions. And SCADA has its integrated functions. One of them is the automatic generation control, or AGC, which regulates power output from generators to maintain balance between generation and load in the power network. So here are my three internship objectives. The first thing is to study the functions of SCADA. And the second thing is to understand the interconnection system for monitoring and controlling power in the regions of Jamali, which is controlled by the SCADA at PTPL and WP2B. Then the last thing is to learn how is the AGC process as the frequency control for all power plants in the Java Bali system and its response to frequency system reduction. So here it is my internship time and location from 8th January to 23rd February, and it is located in here. Okay, so next part I will explain the company profile. So UP2 Bali is one of the PLN business activities which being responsible for the distribution of load and generation management of electricity in the parts of Jamali regions, and it also plays a crucial role in managing the electrical distribution network and ensuring the availability of stable and reliable power supply for customers. And WP2B Jamali also has several subunits, such as we know that in the Banten, and also the following regions across uh, the regions of Jamali, such as in West Java and East Java, and also we have in Bali, and also we had a few of them in the West Java. This is one of my subfield which I used to work at, which the name is the SCADA and automation subfield. And this field was responsible for maintaining the SCADA system to work with optimal conditions, such as monitoring and controlling the GCC load control function in a real-time condition. Okay, so the third thing is the fundamental theory. So it is the principles of SCADA system that consists of three parts, such as the master station, that is equipment installed in the load control center. And the second thing is to remote station. It is equipment installed in the substations and power plants. And also we have interconnection links that name is communication link. And the next part is the automatic generation control, which is an automated system that represents the advantages of technology in one of the SCADA applications. And it is being responsible for adjusting the power output for multiple generators to be distributed to various power plants in response to changes in the load quantity. And also this system requires an electrical network that ensures the load and generation have a linear balance over time by adjusting the system frequency based on the generator output regularly. So here it is the formula for the frequency system balances. And here it is the characteristics of how the frequency system is balanced throughout the power systems schematics. And also we continue to the flow of the frequential regulation that consists of three things. So the first thing is the primary regulation, or as known as free governor. We can see in this phase from 0 to 20 seconds that responsible for quickly addressing load dynamics when the frequency drops. And the second thing is the secondary regulation, which is widely known as AGC, that is generating units from the control center for adjusting power output for generating units to maintain system frequency stability. And the third thing is the tertiary frequency control, that is resetting generation while considering economic factors. So the next part, we would like to describe the activities and discussion. So the first thing that we would like to do is to know how is the AGC requirements parameters. So there are several parameters on it. How this illustration demonstrates on how the signal is processed from the generation units to the SCADA systems. Then the SCADA systems will proceed it and take it as an information system in that computer system. So the next part is to the activity of the AGC monitoring flow. This AGC monitor system frequency to calculate ACE, indicating the deviation between the actual and reference frequency. Then the ACE detects the frequency discrepancies by multiplying frequency deviation with the bias offset. Then the LST collaborates with the economic dispatch to optimize the generating unit allocation and reduce operational costs. This way, I would like to do some AGC monitoring activity flow by using this website. This website provides a real time for monitoring AGC in the Jawa Bali system. Then we can see how the response of the frequency system while it has dropped dramatically. So here is one of the main points of the analysis, which is the trip events if in the PLTGU Tambak Lorok. And we can see in this graph that the normal frequency from 50.05 to 49.7930, indicating that instability with a deviation of 0.757. And this effect will also affect the impacted the total load and generation Jamali system, as well as the overall system of the Jamali. And it shows the imbalance of Jamali system, as well as the intersection of total load supplied and generation power, which indicates imbalance with load increase. And that impacts also affect the fast response reserve monitoring as a cadangan for the power for the generation, which is the optimum value of 500 megawatts, but it dramatically drops to 299 megawatts. And also, it has several impacts for the other power plants, such as the PGU Priok. And we can see that these generation units tends to get increased, as well as the reductions in the frequency system in order to make a balance between the load and generation demands. And it tends to 10% increase in power generation for the Unit 2 and Unit 3. And also it has impacted the PLTA Saguling hydropower plants, and it entirely affected all for overall units in these power plants by experiencing a boost of approximately 30 to 40%. And we can see that this analysis of the system frequency regulation based on what I mentioned earlier before. So the governor phase or the primary frequency control, which lasts for 16 seconds. Then the secondary frequency control, which lasted for 3 minutes. Then we can simplify that those frequency regulations generically to maintain operational stability by providing rapid response to immediate changes. And also we can simplify the analysis of power plants, and we can conclude that this dramatic decrease in system frequency can result in the power generation. This mainly occurs in the increase of high demand, which requires an increase in power capacity generated. And the second thing is during the significant system frequency reductions, the electricity system will utilize available reserve resources. Then the drastic increase in the production of other power plants such as PGU Priok and PLTA Saguling indicates the operator's efforts to balance the power production and demand, as well as the restore system to safe level. So the last thing I would like to describe the conclusion. So the first thing is to, the stratus signals activate AGC for maintaining balance between generation and load. And the second is both of the frequency controller ensures consistency among the system frequency. Then the PGU Prio also support the energy needs by adjusting power production responsively. And the fourth thing is the fast response reserve monitoring ensures quick backup during sudden power drops, enabling effective response to emergencies. So here is a few recommendations which you can read below. Okay, here is the references. Well, I think that's all from my presentations. I'm sorry if there is not enough time to explain it a lot. Thank you for watching me. Wassalamualaikum warahmatullahi wabarakatuh.